Okay, for today I want to review a couple of basics. Like for instance, if I gave you this equation, what form is it in? Oh, wait. 4, 1, 2. What form is that equation in? Put it in the other two forms. I'll give you a hint. One of them is called parametric form. Metric form. 2 plus 4 lambda. Good. Keep going. Equals 3 plus 1 lambda. Sorry, keep going. All right, awesome. And then what form can we change it to next? There's no such thing as lambda form. There's the C, Cartesian. That's also known as rectangular form. They are the same thing, all right? So that means basically you got to get the what out of there? Lambda. Go ahead. Put it in Cartesian form. I'll pause where you do that. Okay, so for this part, we are going to solve for lambda, and we would get something equals something equals something. We need our first something from this getting solved for lambda. So we go x minus 2, because that's the first step in solving it, and then divide by 4. And then the next one would be y minus 3, and not divided by anything, because the lambda is just alone there. And then lastly is z plus 1 divided by 2. Raise your hand if you had those right. Okay, good. Which's got the most information? Vector, parametric, or Cartesian? It seems logical that we couldn't have added any information by changing it to parametric. But maybe you could argue that they're equal, parametric and vector. Is there anything that vector form is missing from this lambda, or that lambda form is missing? You can still, if you know where to look, you can still get the starting point. It's a little more clear in vector form what the starting point is, maybe. Okay. All right. So now that we've got this vector pretty thoroughly analyzed, what if I gave you another vector? Could you tell me if they would intersect or not? I hope you could. I hope you could tell me if, for instance, I gave you x, y, z was going to start at a different place. Does this mean that they can't intersect? Can they still intersect? Yeah. No matter where I start, as long as I draw it in the right direction, it can intersect. Okay. Plus, I'm going to call this mu. And what was it again? 1, 2, 7. All right. Will those two be in the exact same place at the exact same time? Sir.
I was wondering, what is the mu? Is that M or U that stands for it?
It is a Greek letter, and so it's not, you know, I can't say it's a this or a that. I mean, Greek letters have even crazy things that we don't have in the, you know, regular alphabet. So it's just a Greek letter. So you should have said that just for x, for instance, that 2 plus 4 lambda is what I get out of this. Okay. And then on the other one, for x, it's 0 plus 1 mu, which is mu. That's kind of nice because it tells us mu is, because 0 plus mu is just mu, mu is equal to 2 plus 4 lambda. Okay? The next equation, let me get this out of here, is 3 plus lambda equals 2 plus 2 mu. And if mu is really 2 plus 4 lambda, I can put it right there. Now I'm going to multiply it out. Times 2 is 4 plus 8 lambda. I'm going to subtract lambda from both sides. 3 equals 2 plus 4. Well, I might as well add those. 2 plus 4 is 6. Plus 8 minus 1 is 7 lambda. And then I'm going to subtract 6 from both sides. So negative 3 equals 7 lambda. So therefore, lambda, all of a sudden I can't draw lambda, is equal to negative 7/3. Thank you. Add it upside down. All right. And if lambda is negative 3/7, I should be able to put it back into here and figure out the answer for mu. But here's the sneaky, terrible, awful thing that I did to you. These don't actually touch. So what are those? And how would you know that they didn't work? Yes, sir. Okay. What if I told you their paths don't even intersect? That was a good guess. It was a good guess that their path, because that's a common thing we do. Paths intersect, but not at the same time. That was this thing. Yes? Just because an answer is negative doesn't mean that it's not working. That's an okay thing to happen. All right. What equation haven't you used yet? If you would, that would be great. What? The z. The z equations. All right. So if you look back at the originals here, the problem is when I put in my two answers that I got and are supposed to work, then it should work in here. That z is 1 plus 2 lambda should equal negative 1 plus 7 mu. And they won't. When you put in the numbers that I just gave you, they won't come out. And therefore, that equation comes out to just a not true statement, like 3 equals 7. All right, so I just wanted to warn you that you can't just look at two equations and solve the first two and go, oh, so I know the answer. You have to actually look at the third one, and the third one can verify for you if it actually worked or not. All right, so these two do not cross. Yes, sir.
So if the thing's not true,
If the what? If the third equation, which is this guy right here, it can be your truth like verifier. Did it actually work or not? Because this equation would be negative 1 plus 2 mu equals the other one, which is negative 1 plus 7 mu, or 7, sorry, I said mu and I meant lambda, equals negative 1 plus 7 mu. That's not a 7, it's a 1. There we go. But when you substitute in the values that I just gave you a second ago, it doesn't actually work. We figured out that lambda had to equal negative 3/7. Well, of course, I can put that in there, but then when you put in the actual answer you get for mu, it won't be the same. And so moral of the story is that these can be tricky. You sometimes have to do every single part of it to figure out that it didn't actually work. All right, one more thing. What could I have done to make it so that these two lines were parallel to each other? Because would you agree, if I've got two vectors and they are truly parallel to each other, that they would have never touched each other unless they were on top of each other? You know what I mean? All right. So, or the other option, of course, instead of parallel, what's the other thing you can do? Perpendicular. Yes, sir.
You have, or like, how would you determine if they would cross, but just not at the same time? Is that just like you and the
You're getting ahead of yourself. That's a long conversation. Okay, so let's Let's do that one later. All right, so I'm going to give you a vector, new one. Ready? X, Y, Z starts at 0, 0, 0, nice and simple, and adds lambda 3, 1, 5. So it's moving 3 to the, what is that first thing? Right, left, or, okay, so 3 to the right, and then 1, what? Up 1, and then 5, what? All right, good. So let's actually place that in the room. So I got to go 3 over, so that's about 3 feet over. Now where? Up 1. I should move the ball in there. Okay, so up 1. Okay, now what? 5 out. So it needs to be about there. All right, so then I'm going to place it here. Should be able to drag it over there. That's a better spot. There we go. Okay, now sit still. That's only about 2 over. Twist it. Come on, I'll twist a little bit. There we go. 3 over, 1 up. Ooh, I got to get it up higher. All right. Isn't that cool? Oh, higher. Stay. Okay. 3 over, 1 up, 5 back. Oh, it's not back far enough. All right. Can we imagine that it's 5 back? Yeah. All right. Good enough. All right. So then generally, I know it's not quite back 5. It's like 4 back 3, but generally it looks something like this. Okay. Now, something that is parallel to it. I want you to write me an equation of one you think would be parallel to it. Just think it through. Write me an equation for any vector that's parallel to it. In a moment, I'll ask you to turn your iPad my way to show me that you found your best guess, a vector that would be parallel to it. Okay, so you could have started with any point. This is kind of irrelevant. If I had started with 1, 2, -1, fine, wherever. What's important? Same slope. And it's like, think of it this way. That's kind of like the slope. Think about it. If I start at some other point, I just said 1, 2, -1. Let's see where that is. 1 over 1. Let's actually start from that one. How about that? Okay, so that's 1 up 0 and out towards you 1. 1, 0, 1. Okay, I'm going to use that one just because I already have a ball in the room that's at that exact spot. Did I do that right? 1, 0, 1? Sorry, -1, 0, 1. You're right. There we go. Okay, now I've got that ball in the room so you can see this. Do you get, if I want it to be the same as this one, as far as its direction goes? Okay, then if I start here, I'm going to want to go, think about it. Aren't I going to want to go to the same things? I want to go in the same number of little ticks, left, right, up, down, etc. So I still need to move. If this one's going to move from this spot, it's going to go 3 to the right. Don't I want this one to go 3 to the right? So I hope that makes sense to you. All right. So that's parallel. How about perpendicular? It's not as simple as it is in 2 dimensions, where you can just take the negative reciprocal. Do you remember that? If the slope is 2, then you want a slope of -1/2. Exactly. It's not that simple. What it is you take the dot product of these 2 things, and if they equal 0, you've found the one that's perpendicular to it. Okay, now picture perpendicular again. This is the one vector. It's the one that my cat didn't chew on. Okay, and I'm figuring out how to mount that. I've got an idea. He chomped on the end. If you look at the little holes, he got the end of it, but didn't get the tip. So anyway, got this vector here, and I want the other vector to start here and be perpendicular to it. You get what I'm saying? Well, we can get it to be perpendicular, as in make a right angle with it. And there's a lot of different ones that would work. If their dot product equals 0. So let me just give you one, and you tell me, does its dot product equal 0? The first one's a 1, yes. I'll put it, center it better. With the dot products now equal 0. Okay? Then that worked. Could there be another one that would be perpendicular to it? Hint, think for a second. Do you get that there's a lot of ways for something to go through this point and be perpendicular to this one? Do you get what I'm saying? I'm holding them up in class, so it's hard to see on the video, but all right. So that's perpendicular. How about that? Isn't that perpendicular too? I'm trying. All right. There's a lot of different ways to make it perpendicular. Now, that's parallel. It's supposed to be. And that can be perpendicular. That can be perpendicular. Anyway, there's a lot of ways to be perpendicular. I would like to give you the option now to give me another combo that starts here and its dot product has to equal 0 is the only thing you really need to know. What combo of 3 things would go with these 3 things and make it perpendicular? Can't use the same one I just did. Do something different. Yes, sir.
So, we want it to be 0 in the equation, we make the fraction 0. Inverse cosine of 0.
Oh, I just love what you just said. Would you say that again? In the equation. What equation are you talking about?
The equation, inverse cosine of the dot product.
There's this formula that's got the angle between them, right? And what is the angle between them if they're perpendicular? So we want this to equal 90. So we want the theta to equal 90. So cosine of 90 is going to come out to 0. So what does that force the dot product to be? Because this equals 0 when this is 90, then that must equal 0. That's a great observation and very mathematical of you. All right. So then, it doesn't really change your answers here. Your answers, the dot product just needs to equal 0. He's just trying to explain. You know, he figured out in his head why the dot product has to be 0. Because if the angle's 90, cosine of 90 equals 0. So that has to equal 0. All right, so there's unlimited combinations here. I shouldn't say it, really. Using whole numbers, there's probably isn't. But there's going to be quite a few you could come up with. How about that? Mr. P, do you have one? Makes the dot product equal 0. Okay. I'll let you ponder one while somebody else gives me one. Remember, you just have to make this times this, and that times that, and that times that, all add up to 0. Yes? All right, how am I going to prove if she's right or not? Going to do what? Do the dot product. So 2 times 3 makes 6, plus 4 times 1 is 4 is 10, and then 5 times negative 2 makes negative 10. Cool, dot product 0. I guarantee you that one's perpendicular. Yes? Okay, and that's cheating. You're right. If you use the 0 vector, why is the 0 vector? Well, I know when you go 3 times 0, 1 times 0, and 5 times 0, it equals 0. But it's kind of cheating. But why does the 0 vector for sure be perpendicular to that one? It is all the directions, which would include perpendicular. So it's perpendicular, and it's not perpendicular. So that's the problem why I wouldn't accept 0, 0, 0. All right. So, true. But if the test question just said give an answer that is perpendicular, I am going to make sure to put in there you may not use 0, 0, 0. Okay. Anyway, I get what you're saying, and I have every right to mark it wrong, but I generally am one of the teachers that does follow. If the directions say this, and they do that, then I'll give you the answer. Except, for example, you can always make it ludicrous. Often it says find x. And if you're that kid that goes, it's right there, I'm not going to give you credit for it, even though technically you follow the directions. Okay, anyway. So, there's a lot of different answers you could have given. Somebody give me another one that would have made the dot product equal 0. Yes, ma'am. All right, and I'm going to double check it. 2 times 3 is 6. 1 times -1 is -1. 6 and -1 adds up to 5. -1. And there we go. Good. That is perpendicular. All right. Now, there's unlimited ones, so we don't need to give more. But last thought is, just think for a second. If I put in, I force you to make that 7. I force you to make this -2. Can't you find something that will make it equal 0? Yeah. I don't know what it is, so I'll put A there, but then couldn't you write a little equation and say this times this, and that times that, and that times that equals 0, and then just solve for A? Yeah, you can force it to be perpendicular if you can only control one of the directions. Thinking in 3D is tough. All right, please do figure that one out right now. What does A have to be if it's X is 7, the Y change is -2? No, it's just an A. That was left over from their original problem. Just A. Figure out what A has to be to make it work. Yes, it's a fraction. That's okay. 3 times 7, 21. 1 times -2, -2. 5 times A, 5A. And they have to add up to 0, and then you just solve it. Okay, so I think it's 19/5. Is that right? -19/5? There we go. Is it plus or negative? I'll check quick. I'm going to add, I'm going to subtract 2 makes this 19. This is negative. Yeah, it's 5A equals -19. So then, yeah, it's got to be -19/5. Okay. So it's really, there's a lot. In fact, there are infinite answers. It's just the ones that you could come up with that are whole numbers that would stay inside the room here would be limited. Other than that. All right, so now the actual, I'm going to cut this problem back a bit. I just want you to find this plain question. It's number 2 on last night's homework. I'm going to give you time to do it in class right now. So basically, I'm just adding to your homework this problem. So I'd like you to try this problem right now. And we're not doing all of it. It is an easy one. We're going to do parts A and B, and then we're not going to do C. That one took forever and a day. But just parts A and B. There is a little part 2 of B, so by the red plane there, but you can skip this part. All right, pause for a second. Let me try that one. Now, okay, I need to get going here. If you're not done, at least you hopefully have got it kind of close. Okay. Here we go. Number 1, or part A, the coordinates of A. It was just saying it in a way that could possibly confuse you, but A is just the point it started at. That's all they're saying. It passes through point A. Well, this passes through this. And p seconds later, it has passed, after it has passed through A, well, that would be this part. P seconds later, it's gone to another point, right? 1 second later, it would have gone to, for instance, put a 1 right there. You don't have to have done this. I'm just saying 1 second later, it would be at what? 3 minus 2, which is 1. 4 plus 3, -4 plus 3, which is -1. And 0 plus 1, which is 1. So this is where it is at time 0. Here's at time 1. And how far apart are they? This is how far apart they are. This is where it moved so it could get to here. So this is like directions on the movement or the direction, and that's kind of like the slope a little bit. But anyway, so the answer to this is just that. It's just 3, negative 4, 0. That's what A was. It was just a fancy way to say the starting point. Next, the speed. The speed is, remember, we just said that's the distances it went. So that you wouldn't go the long way, which would be go 2 to the left, up 3, and then back 1 towards us. It's kind of hard to see that in 3D on a 2D board, but you wouldn't go here to here, here to here, and then there to there. You'd take the shortcut, which would be the resultant, which is like there to there. Again, hard to see in 3D. It's actually coming towards us, that arrow. But it would be the square root of negative 2 squared, which is 4, 3 squared, which is 9, and 1 squared, which is 1. That adds up to the square root of 14. That's part of your answer, but that's the distance it went. And how much time did it take to do that distance? 1. Divided by 1, and that's in seconds. And this was in meters. And therefore, the answer is root 14 meters per second. If you really want to make sure it's 1 second, well, then put in 1 for your t, or your lambda, or your p, or your mu, or whatever they've put there. And then you'll see what the point is, and then you'll be like, oh, wait a minute, I guess it's just these numbers again. It will be. Okay. Next one, after 7 seconds it passes through point B. Well, then we just stick in a 7 here. Save me some time. The numbers are fairly big. What did you get when you stuck in a 7? Raise your hand if you concur. All right, good. And now, think about this. The speed was this. If you go 7 times as far, but you take 7 times as long to do it, isn't the speed going to be the same? Yeah. All right. So when we do this, what's the distance that is traveled? Well, what was the distance it traveled in 1 second? The square root of 14. That was the distance for 1 second, and it's 7 times that far. 7 times square root of 14. Could have done it a lot harder way if you wanted, but that's the easy way. All right. Now, I know you could have found the original starting point, and you could have found the new point, and you could have found the distance between them, and done all of that, and it would have worked, but hopefully, if you actually figure out what your answer is, it will come out to 7 times root 14. It's kind of like using a unit vector. Remember the unit vector thing where you shrink it down to only 1 long, and then you can scale it up to be anything you want? Well, if I know the speed is root 14 in the first place, or sorry, the distance it's going is root 14, which is also the speed, which is a weird concept because it's dividing by 1 second. Okay, the distance is root 14. Then I can just say, well, it's in 7 seconds, it's going to go 7 times that far. So it's a lot like the unit vector thing. All right, now your homework for tonight has 2 pieces, one of which has a problem on it that often confuses people. You're so used to 3D now. I'm going to bring you back to 2D, and it might give you a little bit of whiplash. If I have 2 compass roses like this, okay, and it goes like this. This is not in 3D where that would be like a right angle in 3D. It's not. Think 2 dimensions. Do you get how a right angle would be to here, and this is more than 90 degrees? How much more is it? Well, you can figure that out from the rest of the problem. Just know that this angle here is not 90 because it's not 3-dimensional. This is just a 2-dimensional triangle that you're trying to make. And what's that thing called where if I add this plus this, it ends up being this one? What's that thing called again? The resultant. Don't forget to draw those in on your little homework quiz. So that's what's happening. Next is your homework quiz. And then your homework, the thing you take home and do at home, is this white one. I will not hand that out for a bit so that you can get through this orangey one first. Your homework is this. Sir. Pausing for